Don't leave. Come and have a seat. So my name is Ben Wu. I'm the Managing Director of Neurolytics. We're a market research firm where we're delivering research around relevancy and also business value. But you're not here to listen to me, as evidenced by the number of people leaving right now. When I talk to you, when you think about flash memory, most people think about the concept of SSDs, storage systems, etc. But it's more than that. Flash memory is about the delivery of high-performance, persistent storage. And it just doesn't have to sit on an SSD. It doesn't have to sit inside a storage system. It can also sit as a memory module. So the person I'm introducing you to is the CEO and co-founder of Diablo Technologies. His name is Riccardo Badalone. He has a long history in the design of chips, firstly at Matrox and then over at Nortel. And about 12 years ago, he started Diablo Technologies. And what you see today is over a decade's worth of development to bring flash into a different module, which is inside the server to assist, and in some cases to replace DRAM. Ladies and gentlemen, Riccardo Badalone.
Okay, good afternoon, everybody. It's a real pleasure to be back, and thank you, everybody, for giving me the opportunity to speak again this year. So today, I wanted to talk about something other than storage, and I'm really excited about the concepts that we're going to talk about today and the technology that we're using to help kind of make things change around us. And one of the things that people really talk about often is social media and how many people are connected to the internet. And the word exponential kind of means that it's not doing this, it's kind of just doing this. And at some point, it gets unmanageable, either in a good way or in a bad way. And so when we look at the number of devices, we went from single-digit billions to now hundreds of billions things connected. And the interesting part is the new reality around us is that we're now starting to talk about tens of trillions of things connected to the internet. And what's unique about this and interesting is that the concepts of big data and the concepts that we're used to around data ingestion, data analysis are starting to not apply. And so we have a traditional hierarchy around us and a data center that's built around processors and memory and storage and a network that were kind of designed and built and architected around the 1 billion things. And when we start talking about trillions of things, that connectivity is not linear. And so the things that are connected themselves are generating more and more data. And these are just connections. We're not really talking about the amount of data that they create. And so really, we're talking in the next 3 to 5 years about having to solve a completely different problem. And that's kind of why I'm here today, to talk to you about solving that problem. You just have to look at the ticker stocks, look at the performance of the companies that are listed here, and you'll see that they're in a race. And the race is to win the internet. And winning the internet is a really important thing for all of us in the next 5 years, okay? You can see the growth of the companies. You can see the tremendous breadth of offerings where search companies are becoming turnkey service providers to us in our daily lives, and they're kind of taking over, right? And what that means is that what we traditionally see as what we call the enterprise, right? Where there's the client, it's kind of like me and you know, the regular everyday user. And then there's the businesses. And I always had this concept of client and enterprise. Well, the enterprise is changing. And when we talk about the server market or the storage market, it's also changing. And it's changing in a way that might be too fast for some of us to realize. So, IDC said, okay, today, almost 20% of the servers are in a class called hyperscale. That kind of means that it's a really generic, very stripped down, two-socket type server with not a lot of value added into it necessarily, just kind of generic stuff, memory, processors, simple network. But there's tons and tons of them connected in a data center, and they're working together in unison on the internet or in the cloud to just answer your questions or just give you the information that you need. So 20%, that's about 2 million servers out of 10. Well, in just 2 years, they're predicting that 5 million out of 10 are going to migrate into this class of servers. Now, for those of us that are in the business and that are selling into the server industry, this is very important because the type of server, the connectivity of that server, the usage model of that server is now changing from maybe a small and medium type company that buys 50 servers a year or in its lifespan is now looking to basically just go to somebody and say, hey, I need X, Y, Z done. I'm going to pay you every month, and it just gets done. They're not going to buy servers anymore. This is important. So then the next thing is we're not even really beginning to add sensory data that allow automation. And so even the type of data that the hyperscale is treating today really has mostly to do with me and you, and not necessarily services that are for me and you. It's reacting to what we want in that moment. It's not actually working around us in tandem with some of our business needs. And there are some really interesting examples. We were doing research for this keynote. I said, okay, I want to talk about something that actually personally excites me that I maybe couldn't imagine being possible 10 or 15 years ago when I was a kid growing up. And it's one of the things that we'll talk about later on today, and it's gonna have an impact. So winning the internet isn't just about consuming a lot of servers. There's a price now. There's like a minimum pay to play if you want to have an impact at this scale. And it's becoming a global thing. It's not just a North American thing, it's all over the world. Data centers are popping up. People are deploying, they're building new facilities, they're buying land, building facilities, in some cases building hydroelectric or electricity transits to those buildings, and they're building communities around the data centers, and they're spending at least $1 billion and up. So it becomes now kind of a club, and it's going to become more and more difficult to play at that level because of their purchasing power and because of their scale. And frankly, the incredible sophistication of engineering that they brought into the company that really, really is designed to make things work, 10,000 things at a time, 10,000 servers at a time, 10,000 floors at a time, or 10,000 people at a time. It's all about scale. The other big thing that they're getting very aggressive about in large-scale data centers, which actually starts to create the problem, is that everything is about bringing content and reaction closer to you. So in the past, things like Hadoop were really good at doing large-scale data analysis, but in batches. So you kick off a job, it might take a few hours, but you get a result, and there would be 1,000 servers working in parallel to deliver the result. Huge amount of horsepower, like a lot of latency, but a lot of throughput. And so once it got going, it could produce a result out the other side. With the introduction of Memcache, what happened was they said, okay, well, I need to have some kind of feedback back to the user. When they do a query, when they do a search, I have to return the data as fast as I can. Because people are fickle. I know I'm like that. I just shot myself. I know I'm like that. I want a response immediately. And so what they need to do is they need to have multiple versions of whatever it is that you're going to be looking for close to you. And we're not all located in the same place, right? So if there's something that in Canada I want to read about, and there's something in Japan they want to read about, it's going to end up being kind of cached in two different places, but close to me. And so this started the concept of the feedback loop to the user, but it was pretty simple. You know, it was just kind of about cache heuristics. There wasn't that much analysis going on. But what's starting to happen is something like voice recognition on your phone, find me the nearest Starbucks, introduced something very interesting, which was that it has to take what you asked them to do, translate it back into an answer, and it needs to be fast. It needs to be reliable. You can't ask for Starbucks and get an Esso gas station list, right? But it happens. And so to provide a better service, they need to collect more information about what your voice sounds like, about your habits, and eventually they will get 10 times out of 10, 100 times out of 100, what you're actually asking for. What you want to be typed in your email while you're driving, or whatever the thing is. So software has started to be designed to work and do more real-time things in memory. And you know, things like Spark, which is an amazing new kind of large-scale data center type software that's coming out, really can use up memory really fast. But the nice thing about it is it can do very sophisticated things for you very fast. But it really needs a media that is more like memory in the end. You know, Redis is an in-memory analytics database that is really using memory. And so the way that we can get more performance even in the internet is by taking advantage of the memory subsystem of the processor, which typically, of course, was always much faster than storage. The other thing is the data doesn't need to be stored, right? A lot of the data that we are using day to day is just kind of there to describe us, and it's kind of there to be in the moment, but it's not the type of thing that you need to really keep around and have accessible to you very, very quickly. And so we want to find a way to deal with the fact that we want more DRAM, we want more services, but we absolutely cannot afford to handle that cost. So what do we want? We want it to be significantly cheaper on a per gigabyte basis. And of course, what that means is you can just put more of it in every individual server, increase the amount of data that is being digested based on your actions or the actions of the things that are connected to the internet, and we can analyze it very quickly. But it's ephemeral. It goes away, or it can be cold stored at some place because we don't need it anymore. The other thing we want is we want to deal with the fact that the power consumption of these data centers is becoming a problem. The hydroelectric bill that Facebook gets every month or every year is huge. And so we want it to simply consume less power when it's just sitting there doing nothing. The other thing is we want it obviously more dense. Now notice I didn't say anything here about we would love it to retain its data or be a storage class type media. Right? For what we're talking about in terms of the Internet of Things, for these 50% of the servers that will be out there in 2017, we really just want a cheaper, lower power, more dense DRAM. We don't want different properties other than the three that I talked about there. We don't want it to do anything more. We just want it to do this. And that will change a lot of things. And it turns out the answer is flash. Now, making flash memory is somewhat orthogonal to everything that we, including Diablo, has been working on for the last 5 to 10 years, which is making it storage. But it turns out that it's amazing to get a media like flash, and obviously even the presentation right before me is showing that the investments, the tremendous momentum behind NAND and flash, you can't ignore that. Can't ignore that flash is becoming one of the central components of the data center. And that momentum really means that we have to find a way to leverage all of the amazing economics that it brings to the table in all the uses and all the different use cases that we can actually think of. And using it as memory is actually one of the new and most important things. So we have introduced the product portfolio, which is called Memory One. It's basically an all-flash memory module. Not part DRAM, part flash, flash, and only flash. It seamlessly integrates into the system and replaces DRAM memory modules. So you can take out a memory module that is DRAM, 16 gigabytes or 32 gigabytes, replace it with a flash memory module that is 64, 128, or 256, and take advantage of the economics of the flash, which are really the three things I talked about on the previous slide. And that's basically what Memory One is. It doesn't keep its data when you turn off the server. We don't want that from memory, and we don't want that from the Memory One flash product. What we want is the economics. And we certainly don't want it to make our applications run slower. We certainly don't want it to make the server do less. And so that's where we come in terms of bringing a tremendous amount of performance and integration that really is in a different level or a different class of a typical storage device, but it's not designed to do the same thing. Optimization points are different, but the fundamental media at the bottom of the whole thing is the same NAND as everything else. And that gives you economy of scale, and that's exactly what people want. So now we talk about massive data. It's not big data anymore. Big doesn't do it justice. It has to be called something different. Massive, enormous, ginormous, doesn't really matter. What we want to do is we want to change results into business intelligence. We want to be able to start the process of automating our businesses and providing services that are really just not something that could be done in the past without things like large-scale data centers. And really, it's about real-time decisions. Okay? And so we'll talk about that a little bit when we talk about some of the practical examples. Where this has a very simple impact is the data that you can basically put in a generic server has just gone up by 4 to 10x, and it hasn't really cost you anything. That concept says it all. That's the economics. Now, what can you do with 4 versions of the car? What can you do with the cars partitioned, but 4 of them in every server? It doesn't really matter. This is where the large-scale data centers, propeller heads, kind of sit down and figure out, okay, how am I going to take advantage of this for my business? But in the end, you now have given them a tool to change the economics of their data center, but most importantly, to give them new capabilities and new services that they can provide to you. So as we were looking and researching, we said, okay, we came about the concept of drones. And I was lucky enough on one of my trips to Asia to actually meet one of the founders of a very successful company in China that is only building drones. And this has become $750 million business. Now, growing up, as a kid, I watched movies, Total Recall, Star Wars. And, you see all these robots flying around, and you wake up, you walk outside your door, and there's things flying around all over the place. But think about this for a minute. It's a fact that people are starting to look into building the infrastructure for automated drone services. So really what that means is that we're talking about things like air traffic control at an exponential level. Open the door, and there are things being delivered, picked up, moving around outside. 100% in the control of computers and data centers. And I think that this is exciting. I think that this is essentially the type of thing that you wake up one morning and you realize, I couldn't believe this was possible. But it isn't possible through the traditional enterprise. It's possible through what we call today large-scale data center operations. So the goal of automation is smart cities, right? Smart health, and smart homes. This is the Internet of Things. But the key here is sensory technology, data ingestion, and driving a different set of economics in the data center. And ultimately, something has to change. And what we're trying to change is this concept that there are only three major elements in a server, right? There's the traditional CPU, memory, network, maybe storage, the fourth. The memory piece has now become dramatically different. The economics need to be different. And so the memory one type concept of introducing flash, purely a system memory, actually solves a really important problem. And it actually gets to where the world is going, which is basically infinite, talking about trillions, infinite amount of data that needs to be digested, acted upon, and at some point moved off into some other server or some other storage media, and replaced with the new and relevant data that needs to be treated in that moment. And so really this is about economics and capacity and clearly lower power to make it deployable. And that will give us basically what I hope to be one day is the automated world. So in summary, what we're looking at doing today with Flash, and this is the Flash Memory Summit after all, is we're trying to change the content within each of the servers to be really more about this media. And we're going to hear about the tremendous innovations that people are making at the device level, but there's also integration at the system. And now we've got a major shift towards flash-based storage media. And we're starting now to see a major shift towards memory class type products that are strictly based on flash. And this is what we're here to talk about today. So come and see us at the show floor. We'll be demonstrating the technology. And thank you, and I'll open it up to questions now. Thanks.
Oh, here we go. So before you guys go, I want to give you two real quick stories. Ricardo talked about how it's the Internet of Things, how things are being driven very quickly and need memory to do so. I want to give you two real quick stories. The first story is about my 9-year-old son who's over there, best dressed 9-year-old kid in the conference. His first word to conjugate was the verb to Google. Kids like him today are not waiting around to find out how things work, right? They want it instantly. I heard this morning a real quick story where somebody was looking for a hotel room, and a bunch of people like myself who use Android and BlackBerry went out and said, I've got an app for that. And the guy who uses the Apple iPhone said, hang on a second, Siri, where's the closest hotel room? It's about the speed of things moving forward. So, Ricardo, I have a question for you. Would you say that the technology you're bringing to the table is, one, about cost savings, but two, most importantly, is about creating business value?
It's entirely about creating business value. Mm-hmm. It isn't really about the cost. It's more about the services that they can provide within the cost constraints that they have, right? And so when you factor in CapEx and OpEx, you have to find a way to make these companies be able to provide you a better service, but within their cost constraints. So
wonderful, really thank you. So everybody, think about this type of technology as a way forward, not just to solve a basic problem. Ultimately, what you're trying to do is take data and make something of it. So, ladies and gentlemen, thank you very much. Thank you, Ricardo Bedolone.
Thanks, Ben.